Hi and welcome to our technical vlog for battery management for multi-rotor platforms. Today what we're going to talk about is how we manage batteries for use with multi-rotor aircraft. We will just touch on the broader radio control models and small unmanned aircraft systems and the different power sources that are used for them. Traditionally, we've used other forms of power. We've used gas turbine engines, we've used internal combustion engines and glow engines. They've predominantly been easier to use on the bigger platforms. Now with battery technology and motor technology, we're starting to see that electric motors and lithium polymer batteries are taking over many of the roles that were previously used by other power sources. Why would we use battery power with multi-rotor aircraft? Primarily because it's a cheap form of power. It is relatively cheap to produce both the electric motors and getting cheaper every day to produce the high capacity lithium batteries that are used. You can have quite a compact package with the batteries providing a high level of power, allowing fast acceleration of the motors, and you can be using up to 8 motors for an octocopter. That's a lot of motors taking a lot of current, and if you were to buy 8 petrol engines, 8 turbines or other form of power, that's going to cost you quite a lot of money. So all good reasons to use electric power. What kind of batteries are we using with multi-rotor aircraft? Well, we can divide that up into different categories. We have power required for the platform itself. We have power that is required for the support systems, power that's required for the payload, and power that's required for the radio control transmitter. These typically are lithium polymer batteries that are used for the actual platform itself. They can be pretty bulky. At the moment they are still relatively expensive, but they do provide a high amount of power in a relatively small but heavy package to keep your platform airborne for anything between 7 and 30 minutes. More recently, we come across batteries that are specific to aircraft type. For example, this battery, which is a TB48 for the DJI Inspire. These intelligent batteries, they have their own monitoring system inside. They are still lithium polymer batteries, but unlike these batteries here that can be used across platforms, these are used specifically for one vehicle. Next, we'll be looking at the support system. So, for example, you can have a ground support station, what's known as a remote pilot station, and these will typically use smaller lithium polymer batteries. These typically run the screen, the receivers for video, and the associated systems that are needed to keep the aircraft flying safely and visible from the ground. As far as payload is concerned, usually cameras, visible spectrum cameras, optical sensors, and those will traditionally use lithium-ion batteries, which are slightly different to lithium polymer. Lithium polymer have a voltage of around 3.7 volts per cell. The lithium-ion, which is a more stable battery as well, is about 3.6 volts. Then moving on to our radio equipment, the majority of radio control manufacturers use nickel metal hydride batteries for their transmitters on the ground. These are typically in packs like these, and the cell voltage on these is 1.2 volts. Battery eliminator circuits and voltage regulators are used on board the platforms to avoid the use of several different batteries and different voltages. They can be used standalone or are becoming increasingly integrated into airborne systems. They can be used to power anything from ancillary equipment used with those systems to the payloads themselves. The last battery that we'll look at is the traditional lead-acid battery, which can be used on the field in place of mains power to provide some on-field recharging capability for any of these batteries. It's usually used with a portable charger, and you can use a lead-acid battery ranging from this, which is a motorcycle battery, up to a bank of several car or lorry batteries to power the charger. Obviously, when you are back home, you'll use mains connected to the same charger to do the same thing.